Welcome to EDU World Space.
So in this video, we're going to talk about question 48 from chapter 20, which asks us, in each of the following pairs of substances, one is stable and known, and the other is unstable. For each pair, choose the stable substance and explain why the other is unstable. So in A, we're given NF5 or PF5. So what's the difference here? So the valence electrons, so for both nitrogen and phosphorus, we have 5 valence electrons. So you think they would behave the same way, but the valence electrons of nitrogen are in the n equals 2 shell. And because of that, we have access to only s and p orbitals. But the valence electrons of phosphorus are in the n equals 3 shell, which in addition to s and p orbitals gives phosphorus access to a d orbital, which is unfilled. So because of that, phosphorus is able to accommodate more electrons around it than nitrogen is. So PF5 is the stable compound, while NF5 is the unstable compound in this case. In B, we have ASF5 or ASI5. So one difference between ASF5 and ASI5 is that fluorine is more electronegative than iodine. So the bonds between arsenic and fluorine will be stronger than the bonds between the arsenic and iodine. And on top of that, if we look at the atomic radius of arsenic, fluorine, and iodine, arsenic has an atomic radius of 185 picometers, fluorine has an atomic radius of 147 picometers, which is smaller than arsenic, and iodine has an atomic radius of 198 picometers, which is actually larger than arsenic. So if you can imagine, if you can surround a basketball with 3 tennis balls, you're able to do that because of the size of the tennis balls. But if the tennis balls were also as large as basketballs, it would be more difficult to fit them around your central atom. So when you have these large atoms as substituents, it's difficult to cram them around a small atom that will take more energy, that'll be less stable. So the more stable compound in this case is ASF5. In C, we have NF3 or NBr3. So the difference between NF3 and NBr3 is that fluorine is more electronegative than bromine, and nitrogen itself is already pretty electronegative. So the nitrogen-fluorine bond is more stable than the nitrogen-bromine bond because of this difference in electronegativity. So NF3 is much more stable than NBr3.